guys, welcome. It's Mr. Flanagan. Sorry I couldn't be here today, out sick. COVID's a terrible thing. What we're going to do today is make sure that we talk about Algebra 2, F3 function characteristics and notes. So just work your way through me. If you need to pause the video on your own time, that's okay. You should be watching this by yourself. That way you can stop and start the video whenever it makes you feel comfortable. Make sure you get all the notes down, make sure you do the extra practice, and make sure you do the online homework knowledge check. When you get done with all of those things, making sure you finish the knowledge check and the extra practice and the notes, you're good for the day. But that's what I need you to do, okay? All right, let's get started. We describe the rate of change for a slope of a graph using these terms, increasing and decreasing. Increasing is the idea of when you're going uphill on a graph. So uphill, and you could guess that decreasing would be downhill then. Write those in your notes. Remember, uphill from left to right. Remember, we're always going from left to right. That would be considered increasing. Well, this would be considered decreasing. If you ever rode your bike on any sort of hill or anything like that, you would know an increasing slope is kind of hard to ride on, while decreasing is very easy, and you can think about it like that. And always this little guy on your bike. Let me do my best at drawing right here. So we're increasing, it's hard to pedal, and then decreasing, easy to pedal. We define these sections of the graph where it is increasing or decreasing as intervals. And we talked about intervals when we talked about interval notation already. And using interval notation, like we just talked about, that's how we're going to describe which part of the graph is uphill and which part of the graph is downhill, or increasing and decreasing. We only want to look at the x values, though. Remember, x is horizontal. And in that case, we're just going left and right. We don't care about how far up and down things go, just if they go up or they go down. Let's go and do an example. Define the increasing and decreasing intervals of the following graphs. So we want to determine which part of this graph is considered increasing and which part of the graph is decreasing. So I'm going to use green here for increasing. So as we can see, we think about where does it start increasing at the bottom of the hill. So we're right here right now, and we want to try to get to the top. So as we go up, 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 and it keeps going on forever like that, we would say it starts increasing at the x value of -1. Remember, we only care about the x values. So at -1 is where we start. So we're going to start increasing at -1. And we never stop increasing as we move to the right, because it just keeps going up, 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 and never stops. So we're going to say infinity on that one. However, there is also a place where it decreases, and that's all the way from up here at the far left of the graph. It goes down, 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 all the way until it hits that point. And that point is the same x value, -1. Remember, just like interval notation, when we did domain and range, we always start with the lowest number first. And we think about what's the lowest number this graph can be that's still decreasing. Well, -infinity. It goes all the way to the left. So it still decreases, starting at -infinity and going all the way until -1. You see that even though -1 is included in these things, based on the graph, like I told you that if it's on the graph, it counts as included. With increasing and decreasing, we're always going to use the parentheses, because that point, that -1 point, is neither increasing or decreasing. It's right in the middle, so we're just going to not include it. So this is your final answer for the first part. Now let's move to the one right to the right of it, and we're going to think about where this thing is increasing at. And we see that it starts increasing from the left, keeps going up, 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 up until a certain point. Think about to yourself, what x value does this point stop at? What x value does it stop increasing? And that's 1. So it goes all the way from -infinity, so all the way all here on the left, and then goes all the way up until a +1 for the x value. And we can think about the same thing with decreasing. We start from that point and work our way down all the way. Down, 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 until we decrease. So it starts at 1 for the x value and ends at positive infinity. Green is for the increasing, while red is for the decreasing. Let's move down. Here, something special happens. It never stops decreasing. It's always going to go down. So it starts over here. Hold on, red. So there are no places where this is increasing, but from the very start, this thing is decreasing in value. So down, 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 down. So it decreases from all the way from negative infinity to positive infinity. Hope that makes sense, because all the way from the left to the right, everywhere on the graph, this graph is decreasing on a hill. Now let's try this last one, increasing and decreasing. With increasing, we start again all the way here, increase, 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 until a certain point is met. And that point is right here, at x value 3. So we increase from negative infinity all the way to positive 3. And do we ever decrease? No, it will always increase. So there is no place on this graph where you're going downhill. It's always going uphill. Just like on the one on the left, where it's always going downhill, the one on the right here is always going uphill. What about the parts of the graph that we can't see? Blank is a mathematical way of describing the ends of the graph which approach blank or blank. And this is really easy to fill in. They are, we say, end behavior. All that means is that what happens on the very far left and what happens on the very far right. And if we remember, if we go all the way to the left or all the way to the right, we should reach negative infinity. Oops, that doesn't look like a great infinity. Let's change that. Negative infinity to positive infinity. And we can talk about left end behavior and right end behavior. Left and right are all about the x values, left and right, while upward and downward are all about the y values. Left and right, again, all are the x values, and y values for the upwards and downwards shift of it. So let's look. All we have to ask ourselves is, what's x and y doing at certain points? So if we're going in this direction, the left end behavior, the left side of the graph, we can say, well, does this go to the left forever? Yeah, it always will. So as x approaches the left, x will be approaching negative infinity. Because you go all the way to the left, it's going, all the way to the left, which is negative infinity. Why we have to think about it a little bit, because as we're going to the left, are we going up or are we going down? If up, then positive infinity. If down, negative infinity. So as y approaches to the left, we're going up, so that is a positive infinity. Let's think about the right end behavior. As we move to the right, we will say x is approaching infinity, because right is infinity in the x term, while y is approaching, are we going up or are we going down? We have to think about that. This one is also going up, so up is a positive infinity. Pause if you need to write that down, think about it a little bit, rewind the video if you need to do some more, and then we can move on to the next one. As we go to the left end behavior in this direction is, again, x will always be approaching negative infinity in the left direction. So we're approaching negative infinity, we're going to the left. You have to think about what's happening to y. Y is approaching, oops, not that way, in this direction right here, in our blue arrow, that's going down, downward, not upward. So we're also, y is approaching negative infinity as we're going down, or as we're going to the left. As far as the right is concerned, this arrow, the red arrow, that one, x is approaching infinity because we're going to the right. Y is approaching negative infinity because we're going down. Remember, this is going down and to the right. And this one is going down, but to the left. Excuse me. Next one. Now we're going to do the third one. In this case, we're going to do the left behavior first, like always. Left behavior, always x approaches negative infinity, while y, what's happening to it? Is y going up or y going down? Well, up. So that means positive infinity. This next one, we see that the graph is going to the right. So x will be approaching positive infinity. Are we going up or down for this one? Well, we're going down. So that would be negative infinity. Last one. This one's a little bit different. On the left, it's very easy. As we're going to the left, x always approaches negative infinity. However, y is a little bit different. Well, not different, just it's going down. So y is approaching negative infinity as well. You say down. Oops, that has the worst spelling I've ever done in my entire life. Down and to the left. Now, this one's a little weird because it doesn't even have an end behavior, actually. This right end behavior, it just stops. It doesn't keep going. It just has this no end behavior. So we would just say none for this because it just stops. It doesn't go on forever. So there is no right end behavior. All right, this last one. Challenge problem. Draw a function on the grid below which exhibits the following characteristics. We have a domain from -2 to infinity, making sure you include -2. A range from -infinity to 5, making sure you include 5. Increasing on the interval from 2 to 5. Decreasing everywhere else in the graph that you can, that's within the domain range. And then as x approaches positive infinity, y will approach negative infinity. So this is about end behavior. So this is end behavior. And then no end behavior on the left side, so it cuts off on the left side. What I want you guys to do is try this problem on your own. There are many different ways you can draw this, so it might not look exactly like mine, but as long as it follows these 6 rules, it's okay. And you can check with a friend to make sure your graph meets all 6 of these criteria. Go do that on your own, pause the video, check it with a friend, and then after you're done, come back, restart the video, not restart, just unpause the video, and go ahead and just look at mine to see if you think it's good. So pause and then start when you're ready. All right, we're back. So we're going to do this together. Domain and range. So I want to make sure that the lowest x value I use is -2. So I know the lowest x value I should use is -2. While the lowest y value I should use, or the highest y value I should use is 5. So 1, 2, 3, 4, 5. So that's the highest y value combined with the lowest x value. So I know I should have probably a point, it would really be helpful at the actual point, -2, 5. So that way I can get started. I know I want to decrease the entire time all the way up until I hit +2 for the x value. Both of these, remember, are x values because they're domain. Increasing intervals is always domain, like the left and right. So let's think about decrease, 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 until a certain thing happens. I hit +2. Then I would like to increase until I hit 5. Increase, 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 increase. Now I've hit 5. So this is at 2. This is at 5. And now my graph should again go all the way down till the end. And just keep going. So I'm just make sure all these things are true. Let's make a checklist. Domain, -2 to infinity, that's true. So that red line is my farthest left, and then it keeps going to the right. So that one's checked off. Good. The range is from -infinity to +5. It goes all the way from down, but stops at +5. So that one's good. Increasing the interval from 2 to 5. Well, we see that from here to here, it's an increasing value. So that's good. Decreasing everywhere else. Let's see. Down here is decreasing. Down here is decreasing. And nowhere else is increasing. So we're good there. The end behavior, as we go to the right, it goes down, and that's good. It does go down to the right. And then no end behavior on the left side. That's good as well, because it's just a point. And that's it. The notes are done. Make sure you work on the extra practice, get that done, as well as the knowledge check online. That should be open for you. If you have any questions, you can email me. I should be able to answer your emails today. If you have any other questions, let me know. And have an awesome day, guys. I will 100% hopefully see you on Thursday this week. Bye, guys.